In this video, I'm going to teach you some basic things in algebra. So one of the first things that you want to know how to do is you want to be able to add and subtract to like terms. So let's go ahead and begin. Let's say if we wish to add 3x plus 5 plus 4x minus 2. So we're adding two binomials. A monomial is simply one term. So 3x is a monomial, 5 is a monomial. But put it together, like 3x plus 5, it becomes a binomial. 4x minus 2, that's a binomial. X squared plus 3x minus 8, that's three terms, so that's a trinomial. 3 is for tri. So how can we add 3x plus 5 and 4x minus 2? How can we do that? The first thing we need to do is add like terms. 3x and 4x are like terms. But what you need to do is add the 3 and the 4. 3 plus 4 is 7, so this is going to give us 7x. And then we could add 5 and negative 2. 5 plus negative 2, or 5 minus 2, that's 3. So the answer is 7x plus 3. Now let's talk about adding two trinomials. For instance, let's say if we have 4x squared plus 3x plus 9. And let's say we wish to add that to 5x squared plus 7x minus 4. Feel free to pause the video and try this example. So what is the sum of these two trinomials? Well, let's begin by adding like terms. So these two are similar. We can't add 4x squared and 3x together because those are not like terms. On the left you have an x squared term, on the middle you have just an x term. So those are not like terms. But we can add 4x squared and 5x squared because they both contain the x squared variable. So what is 4 plus 5? 4 plus 5 is 9. So this will give us 9x squared. For those of you who want a quick review of addition, here's how you can add using a number line. So if you wish to add 4 to 5, start with 5 and travel 4 units to the right. This will take you to 9. So anytime you need to add, travel to the right on a number line. If you need to subtract, travel to the left. Now let's move on. So the next two like terms that we can combine are 3x and 7x. 3x plus 7x, or 3 plus 7, that's 10, and then just carry over the x. That 0 didn't look like a 0. And now the last two things that we can add are 9 and negative 4. 9 plus negative 4, if we use, let's say, a number line, let's start with 9. So we're subtracting 9 by 4. We need to travel 4 units to the left. And so this will be 8, 7, 6, 5. So 9 minus 4 is positive 5. And therefore, this is our answer, 9x squared plus 10x plus 5. Now, what about subtracting two trinomials? So let's say if we have 5x squared minus 6x minus 12, and then minus 7x squared plus 4x minus 13. What do you think we need to do here? So take a minute and try this example. Feel free to pause the video as you work on it. So let's begin by identifying the like terms. So we have 5x squared and negative 7x squared. Actually, before we do that, let's distribute the negative sign. That's actually a better thing to do. Now, the negative sign will be distributed to everything on the right, so all of the signs will change. Here we have an invisible positive sign in front of the 7. So a negative times a positive will give us a negative. And in front of this trinomial, we don't have a negative sign. So we could simply get rid of the parentheses. So right now we have 5x squared minus 6x minus 12. Now to distribute the negative sign, everything will change sign. So the 7x squared, which was positive initially, will now be negative. And the positive 4x will now be negative 4x. But the negative 13 will change to positive 13 because a negative times a negative is a positive. Now let's go ahead and combine like terms. So we can combine 5x squared minus 7x squared. 5 minus 7, that's going to be negative 2. So we're going to have negative 2x squared. Now the next two like terms are negative 6 and negative 4. Negative 6x plus negative 4x. What is the answer? What is negative 6 minus 4? So if we were to start with negative 6 and then subtract it by 4, we would have to travel 4 units to the left. And so this would be negative 7, negative 8, negative 9, negative 10. And so negative 6x minus 4x, which is the same as negative 6x plus negative 4x. So you can read it like this, or you could read it like this, because a negative times a positive is a negative. Either way, it will still give you negative 10x. And finally, the last two that we need to combine are negative 12 and 13. So you can read it as negative 12 plus 13, or if you reverse it, positive 13 minus 12, which I think it's easier to see it that way. 13 minus 12 is 1. So negative 12 plus 13 is positive 1. And so this is our answer, negative 2x squared minus 10x plus 1. Now at this point, what we're going to do is we're going to multiply monomials. So what is x cubed times x to the fourth? What is the answer? When you multiply one monomial by another, let's say with a common base, in this case the base is x, what you need to do is you need to add the exponents. So 3 plus 4 is 7. So the answer is x raised to the 7th power. Now let's understand why that's the case. So what really is x to the 3rd power? X to the 3rd power is basically x times x times x. So what it means is that we're multiplying 3 x variables together. And x is basically x to the 1st power. So 1 plus 1 plus 1 is really 3. So I'm going to write x cubed as x times x times x. Now, x to the 4th power basically means that we're multiplying 4 x variables together. So when you combine 3 x variables and 4 x variables, you get that we have 7 x variables that we're multiplying together. 3 plus 4 is 7. And so that's why we get this answer, x to the 7th power. For the sake of learning, let's try some other examples. So let's multiply x to the 5th power times x to the 7th power, and also x to the 8th power times x to the 9th power. So feel free to pause the video and try those two problems. So this is going to be x raised to the 5 plus 7, and then you just got to add those two numbers. 5 plus 7 is 12, and so that is the answer for the first problem, x to the 12th power. Now for the second one, you just got to add 8 and 9. So 8 plus 9 is 17. Thus we get x raised to the 17th. Now some of you might be wondering, what is x? X is basically a variable. It has a value of which you do not know at the present. But let's say if you have an equation that says 5 plus x is 8. Now x has a specific value in its equation. So what is x? 5 plus what number is 8? Well, we know that 5 plus 3 is 8. So in that particular equation, x is equal to 3. So x is just a variable that can represent any given number. So when you see x, don't let it confuse you. Just think of it as a number that you don't currently know the value of. Now let's say if we have x raised to the 8th power, and let's divide it by x cubed. So what should we do here? Now in a previous example, we saw that when multiplying two variables together, we need to add the exponents. So in this case, 4 plus 5 is 9. But what about when dividing? In this case, we need to subtract the exponents. So it's going to be the top exponent minus the one in the bottom. So 8 minus 3 is 5. Now let's try another example. X raised to the 5th power divided by x squared. So this is going to be x raised to the 5 minus 2, which is x cubed. To visualize it, imagine if we expand x to the 5th power. We know that it's the multiplication of 5 x variables. X squared is simply x times x. Now we can cancel 2 of the x variables on top and on the bottom of the fraction. And so we're left with 3 x variables at the end, which is equal to x cubed. And so that's why this works. Because if you subtract 5 by 2, you get 3. Now what if the exponent in the denominator of the fraction, what if it's greater than the exponent in the numerator of the fraction? What should we do in this case? If we subtract it, starting from the one on top, it's going to be 4 minus 7. And this will give us a negative number. So what does that mean? This is the same as x to the negative 3rd over 1. And whenever you have a negative exponent, you can take the x variable, move it to the bottom, and by doing that, the negative exponent will now become a positive one. And so the final answer is 1 over x cubed. To see why that's the case, we need to expand the original problem. X to the 4th is x times x times x times x. X to the 7th power is the multiplication of 7 x variables. Now we can cancel 4 at a time, and notice that we have 3 x variables in the bottom of the fraction. So therefore, this is going to be 1 over x cubed. And we can see why that's the case now. So anytime you have a negative exponent, you could move it to the other side of the fraction, making it positive. So if I had 1 over x to the negative 5th power, I could take this exponent, move it to the top, and now it's going to be x to the 5th power. You could write it like that, or you could say over 1. It's the same thing. Now let's try some more examples. So go ahead and work on this problem. X to the 5th power divided by x to the 8th power, and also y to the negative 4th. Go ahead and simplify these problems. So for the first one, we can do simple subtraction. So we have 5 minus 8, which is negative 3. Now we need to get rid of the negative exponent. Typically when you're in an algebra course and you want to simplify the variables, your goal is to get rid of any negative exponents. So the final answer is 1 divided by x cubed. Now for this one, we're going to do the same thing. We're just going to put it in the bottom. So the final answer is 1 divided by y to the 4th. Let me write that better. Here we go. And so that's it for these two examples. As you can see, they're not too difficult. Now let's focus our attention on multiplying monomials. So let's say if we have 3x cubed and we wish to multiply it by 5x to the 6th power. How can we do so? The first thing that we need to do in this case is that we need to multiply the coefficients, the numbers in front of the x variables. So 3 times 5 is 15. Next, we need to multiply the variables. X cubed times x to the 6th power. And we know that we can do this by adding the exponents. So 3 plus 6 is 9. So our answer is simply 15 times x raised to the 9th power. So let's try another example. Let's say if we have 4x squared and we wish to multiply it by 7x cubed. Go ahead and try that problem. So in this case, all you need to do is multiply 4 by 7. 4 times 7 is 28, and then we need to multiply x squared by x cubed. And so 2 plus 3 will give us 5. So our answer is 28x to the 5th power. And that's it. Now let's try a more complicated example. So let's say we have 4x y squared, and we're going to multiply it by 8x squared y cubed. So go ahead and try this problem. Now just like before, we're going to multiply the coefficients together. So this is going to be 8 times 4, which is 32. Next, we're going to multiply like variables together. So we have x times x squared. If you don't see an exponent, it's a 1. So all you need to do is add the exponents. 1 plus 2 is 3, so we're going to have x cubed. And then we need to multiply y squared by y cubed. So we need to add 2 and 3. 2 plus 3 is 5. And so this is our answer. 32 x cubed y to the 5th power. Now let's work on some practice problems. So multiply 5x squared y to the 3rd by 6x cubed y to the 4th. And then try this one. 7 a to the 3rd b to the 4th times 8 a to the 5th b to the 7th power. So the first one, we're going to multiply 5 times 6. 5 times 6 is 30. And then we have x squared times x cubed, so 2 plus 3 is 5. So that's going to be x to the 5th power. And then y cubed times y to the 4th, 3 plus 4 is 7. And so it's y to the 7th power. Now let's do the same for this one. So here we have 7 times 8. That's going to be 56. And then a cubed times a to the 5th power. So 3 plus 5, that's 8. And then b to the 4th times b to the 7th. 4 plus 7 is 11. And there you have it. So we have 56 a to the 8th power, b to the 11th. And this is 30 x to the 5th, y to the 7th.